Welcome to This Explainer. You know, we spend so much of our lives communicating digitally, tapping send without a second thought. But today, we're pulling back the curtain to reveal the incredible invisible machinery, the hidden protocols, running under the hood of the apps you use every single day. Think about it for a second. How does an email actually get from your phone to your friend's laptop? It's pretty wild that a message seamlessly appears on a colleague's desktop halfway across the world just a few seconds later. It's definitely not magic, though. It's a highly orchestrated series of handoffs. So, here's our game plan. We're going to break down this alphabet soup of networking acronyms step by step. We'll explore the application layer, how SMTP routes the mail, POP3, IMAP, and Voice over IP before bringing it all together to understand the internet's hidden engines. Let's kick things off right at the top with the application layer. This is really where the communication begins. Picture the TCP/IP framework like a giant layered cake, with protocols like SMTP and FTP sitting right at the very peak. This topmost layer is the closest one to you, the end user. Your data travels up from the physical link at the bottom, moving through the network and transport layers all the way up to this application layer, which initiates the actual communication. Essentially, this layer acts as the ultimate bridge. It creates the software interface that actually lets your device talk to a remote server. It's setting the rules of the road, defining the specific language for whatever task you're trying to pull off, whether that's browsing a website or sending a message. Moving on to SMTP, which is all about routing the mail. Let's trace a real-world action. When you fire off an email, you're using our digital mail truck, the Simple Mail Transfer Protocol, or SMTP. It relentlessly pushes your message from your local ISP server across the wider internet to the receiver's organization server. It is strictly a push protocol. And here's a quick fun fact for you. SMTP is actually super old and was originally built just for plain text. So when you attach a funny meme or a PDF, your email relies on a crucial extension called MIME. That's Multi-Purpose Internet Mail Extensions. MIME seamlessly packages up that media so SMTP can push it right along the exact same route. Behind the scenes, SMTP leans on something called a Message Transfer Agent, or MTA. You can think of the MTA as the sorting facility at your local post office. It looks at the digital envelope, figures out exactly where it needs to go next, and relays the message hop by hop across the internet until it finally hits the server hosting the recipient's mailbox. So the full playbook looks like this. First, you compose your message. Second, it goes to your local mail server and sits in a queue. Third, the SMTP software spots it, opens a dedicated TCP connection, and securely routes it to the destination server. And finally, it's dropped into the recipient's mailbox, just waiting for pickup. All right, the email has arrived, but how do we actually get it onto our screens? Enter POP3, the simple postman. Remember how SMTP pushes mail out to the world? Well, you can't use it to fetch your mail. For that, we need a Message Access Agent, or MAA. This is a dedicated pull protocol designed specifically to reach up to the server and pull your data down to your screen. Our first MAA is POP3, Post Office Protocol version 3. It's a very straightforward old-school method that connects over TCP port 110 to download your mail. Using POP3 is literally like walking down to a physical PO box, grabbing all your letters, taking them home, and leaving the box completely empty for the next day. But as you might guess, there's a massive catch here. Because POP3 is built to download messages locally and instantly delete them from the server, trying to check your email on multiple devices turns into an absolute logistical nightmare. Plus, if your computer crashes and you haven't backed up those downloaded emails, they are permanently gone. The server just doesn't have a copy anymore. Talk about major data loss anxiety. Because we all use multiple devices now, the internet desperately needed an upgrade. And that's where IMAP comes in, the smart sync. The Internet Message Access Protocol, or IMAP, is essentially the internet's magical filing cabinet. Listening on port 143, IMAP lets you securely log in and manipulate your emails without ripping them off the server entirely. You can create folders, flag important messages, and run complex searches, all directly on the server itself. When you contrast the two, the difference is night and day. POP3 is that simple one-and-done download, which was great back when server storage was insanely expensive and you only checked mail on one family desktop. But IMAP gives you that continuous, seamless sync we all rely on today. Read an email on your phone, IMAP flags it as read on the server, and boom, it shows up as read on your laptop later. It's a fundamental shift from local management to server-side management. Okay, we've mastered text, email, and attachments. Now let's switch gears to voice over IP and see how the internet handles audio and your daily phone calls. Voice over Internet Protocol really shows off how flexible the application layer is. IP telephony proves that, to the network, your voice is just another pile of data packets, no different than a text email or the pixels in an image. VoIP simply digitizes your live voice, chops it up into tiny little packets, and fires them across the internet in real time. This was an absolutely revolutionary transition. We completely moved away from the old, dedicated copper wires of plain old telephone service, affectionately known as POTS, and the legacy public switched telephone network. Today, your voice, fax, texts, and multimedia all cruise down the exact same broadband digital highways as your standard web traffic. All right, let's wrap up everything we've uncovered today about the internet's hidden engines. To perfectly sum up our journey, SMTP is the workhorse pushing your data across the globe. Once it arrives, POP3 or IMAP acts as the retriever, pulling that data down to your screen through ports 110 and 143. And VoIP takes that very same packet switching infrastructure and uses it to translate your live voice into a global digital network. They all have totally distinct jobs, but they work together in perfect harmony at the application layer to keep us connected. It's pretty amazing, right? These protocols run our world today, scaling from a handful of old university mainframes to billions of smartphones. But it really makes you wonder, as we push toward things like virtual reality, instant global translation, and real-time holographics, what new hidden engines are we going to have to build from scratch for the next generation of digital connection? Definitely something to chew on the next time you tap send. Thanks for hanging out with me for this explainer, and keep exploring.